Right, happy morning student. And now we will start relational algebra queries which we already discussed, but it is only a revision for you on relational algebra queries. I would like to revise the queries which we already discussed. You can expect some questions from your examinations, external and internal examinations on the relational algebra queries. And once we revise the selection operation, projection operation, and of course the intersection set operations, union, intersection, difference, cross product, division operation, join operations, that is equi-join, conditional join, and natural join operations. Let us have a discussion on all these. We revise these topics already discussed, but still I'm revising those topics. Just a recap of the previous class. Join is used to combine multiple relations. Whenever you are working with the multiple relations, we make use of join. So join is used to work with multiple relations. Right, students. We'll have a recap of the previous class. We made use of joins, that is, if at all you are interested to join multiple tables or if you want to extract data from the multiple tables, we use the join operation. Under join, you are having the conditional join operation, where conditionally you can club the multiple relations and you can get the data. That is nothing but the conditional join operation. And of course, you are having a equi-join, that is, the two relations should have the common column, that is a column with a common heading, and the values should match. The values of the first relation and the values of the second relation of the common column should match. Then it comes to equi-join. On equality basis, we will be joining the tuples of multiple relations. That comes to equi-join. So joining multiple relations is a join. And based on conditions, if you are able to connect the multiple relations, that is called condition join. And of course, you are having equi-join on equality basis of the column values. We will be joining multiple relations, that is called as equi-join. And of course, you are having as a natural join. As you know well, it is equivalent to equi-join, where the duplication of column will be eliminated. On equality basis, the multiple relations will be joined, which comes to natural join. Default is a natural join. That is, the columns there should be a common columns in the relation 1 and relation 2, and the values should match. So by default, the natural join is being considered while joining the multiple relations. It is equivalent to equi-join, but duplication of columns are eliminated. Duplicate columns. Without duplicate columns, the natural join comes out. And of course, there is a division operation which we discussed. A relation can be divided by another, and based on the division values, the resultant relation will be obtained. That is a division. And also in our last class, we worked out with some examples. In this class, let us revise all the examples what we discussed with some additional examples. The agenda or the outcome of today's class should be a revision of join, condition join, equi-join, natural join, division examples, and all these we are going to revise through queries. Through queries, we are going to revise the relational algebra queries. We are going to revise all the topics which we previously discussed. Suppose this is a relation. Dear students, all of you be alert. We are going to evaluate some queries using relational algebra. List out data of sailors whose ratings are greater than 8. Your question is, list out the data of sailors whose ratings are greater than 8. You are having sailor ID, sailor name, ratings, and age. This is a sailor table. Let me call it as an S2. S2 is a sailor table. Sailor ID, sailor name, ratings, and age. This is S2 table. That is a sailor's table. Your question is greater than 8. He asked to list out the sailors whose rating is greater than 8. So I am using selection operation. This is a selection operation. So this is nothing but the selection operation. I am using the sigma, which is a selection operation. From where? From S2. I should get from S2, from the relation S2. On what I should use the condition for horizontal fragmentation, I should use the condition rating greater than 8. Rating greater than 8. Rating greater than 8. That is 9 is greater than 8 and 10 is greater than 8. And hence select the tuples means the rows. Select the rows whose rating is greater than 8 from S2. From the table S2, I want to select the tuples whose rating is greater than 8. And hence you get the output as 28 UP 9, 28 UP 9 and 35. Age is 35 years. Similarly, 58 Rusty 10, his rating is greater than 8. And so this tuple is resulted and this tuple is resulted. Why not these tuples? The rating is not greater than 8. You're not getting this and this. You're not getting that and this. These two you're not getting. The reason the rating is not greater than 8. It is 8, it is 5. It is not greater than 8. And hence you got only these two tuples as per the relational algebra expression. We discussed all these in the previous classes. I'm just revising. Dear students, just a minute. You please go through this query. Yeah, I'm proceeding to the next concept. Dear students, you need to note down. The writing gives you a practice. You need to note down the queries. Next example. You observe this. The same question. Instead of rating, he's saying age. List out data of sailors whose age is greater than 40. Whose age is greater than 40. The sailors' data is in S2. S2 is a relation. This is the relation. From the relation S2, I want to select the sailors whose age is greater than 40 years. Whose age is greater than 40 years. Then I'm selecting, that is a select operation, sigma, select, age greater than 40 from S2. Whose age is greater than 40 from S2. If you observe this 35 age is not greater than 40. This 35 is not greater than 40. This 35 is not greater than 40. Age is greater than 40 is nothing but it is only a lubber. So you get the output of lubber 31, lubber 8 and 55.5. You get the complete data of Mr. Lubber because his age is satisfying this criteria. The query, that is age greater than 40. Age is 55.5 which is greater than 40 and hence you are getting 31, lubber 8 and 55.5. The instance of, it is an instance of S2. From S2 you got this instance. This is a result for this query. Yeah, you please go through this query for a minute. Let us proceed to the next concept. We are working on selection operation. Now you observe this. Slowly I am using logical operators. I am introducing logical operators. This is AND operator. That is nothing but AND operator. I am using logical operators. Now list out whose rating is in between 5 and 10. Whose rating is in between 5 and 10. Select. From where? From S2 you need to select. From S2 you need to select. That's what I am specifying. Select from S2. What you need to select? Rating greater than 5 and rating less than 10. Rating greater than 5 and compulsory. Rating should be less than 10. It should be greater than 5 and less than 10. And if you observe this, rating greater than 5 and less than 10. Rating greater than 5 and less than 10 is nothing but UP. And hence you go in output you got UP. You got UP in your output. Greater than 5 and less than 10. 8. 8 is lubber. His rating is greater than 5 and less than 10. So you got lubber as output. And should be greater than 5. No, this is wrong. Greater than 5. You will not get this. Greater than 5. You will not get this. It is not greater than 5. 5 is greater than 5. That's false. You will not get it. And Rusty greater than 5 and less than 10. This is 10. And Rusty, even Rusty you will not get. Because is it greater than 5? Yes. And less than 10? No. It is 10 is less than 10 is false. And hence in your output, the output instance from S2, the output instance from S2 is nothing but UP and lubber. You get UP, you get lubber as your output. Here slowly I am introducing the logical operator, AND operator. Select rating greater than 5 and rating less than 10 from S2, from the sailor S2. So this will be the output. This is the result. This is the result of that query. Yeah, just a minute, please go through. We proceed to the next concept. Here, AND operator, logical operators. We are using logical operators. List out whose rating is greater than 5 and age less than 40. Whose rating is greater than 5. Rating should be greater than 5 and age should be less than 40. Both the conditions should satisfy. It should be greater than 5 rating, age should be less than 40. So let me say this is S2, that is a sailor's table. S2 is a sailor's table. Select rating greater than 5. Rating greater than 5. Here this rating is greater than 5, this rating is greater than 5, and this rating is greater than 5. And age should be less than 40. Age is less than 40. Yes, this is true. Age is less than 40. This is true. Age less than 40. That is true. Age less than 40. This is false. This is false. So though the rating condition is satisfied, age condition is not satisfied. Your age should be less than 40. Here it is not satisfying the condition. It is satisfying the rating condition but not age condition. And coming to this, rating is greater than 5. Yes, rating is greater than 5. And age should be less than 40. Yes. And this is 40, less than 40. This is satisfied. And hence you in output you will get UP and you get Rusty as the output. UP and Rusty is the output. So these are the instances from S2 which is satisfying this condition, this query. These are the instances, UP and Rusty are the instances which are satisfying the given criteria or the given condition as per relational algebra expression. Similarly, you observe here, list out rating is greater than 8 and age greater than 40. Just I am using OR operator. Here we are using AND operator. Now here we are using OR operator. OR operator. Any one condition is true, we can accept. If any one condition is true, we can accept. Rating greater than 8 or age greater than 40. Or either this or that. Rating greater than 8. So the first one is satisfying, rating greater than 8. Greater than 8. Second not satisfied, third not satisfied, fourth is satisfying. So 9 and 10 are satisfying as per the rating criteria. Or age greater than 40. Coming to the age greater than 40, this lubber is satisfying. Lubber is satisfying the condition, age greater than 40. Here age is greater than 40 is false, false. And hence you will get output as UP. UP will be in the output. Output you get UP. And output you will get lubber. Because age condition is satisfied, you will get lubber. Lubber. Because age condition is satisfied. And you get Rusty. You get Rusty. Output you will get Rusty. You get Rusty. So UP, lubber and Rusty. UP, lubber and Rusty. This is the output of this. This will be the output of this. UP, lubber and Rusty. So here in this above example, I am using AND operator. Both the conditions should satisfy. And coming to down below, I am using OR operator. Any one condition should satisfy. Any one, either this or that. Either rating condition or age condition. Any one condition should be satisfied. Right? You please go through the queries, both the queries, just a minute. Hope you had gone through these queries. I am just proceeding to the next concept. Queries are simple. It is very simple. You please try to understand. Quite comfortable and damn easy if you are able to understand the basic concepts. I am using pi. Find the sailor names. Here he is specifically saying not all details. He is asking for only names and ratings. Find sailor names and ratings. That's all. I want only names and ratings. I don't want their age, their sailor ID. I'm not interested in seeing the rest of the data. I don't want this age. I'm not interested in age. I'm not interested in sailor ID. In the question he is clearly specifying he wants sailor names and ratings. Names and ratings. You require only names and ratings, sailor names and ratings. Select sailor name, comma rating from, this is nothing but, I'm sorry, this is a project operation. The pi is nothing but project operation, project. I'm asking to project sailor name and rating from S2. So this is S2. So you get only sailor names and ratings are extracted and that is being projected. You observe here only names and ratings. One is UP, Lubber, Guppy, Rusty, and ratings 9, 8, 5 and 10. These are the ratings. So you came to know how to project. This is called projection. Projection is a vertical fragmentation. Selection is a horizontal fragmentation, whereas the projection is a vertical fragmentation. You get vertically the required columns you will get. That is the reason it is called vertical fragmentation. You are getting S name, that is the sailor name, and rating of the sailors. This is what you are getting it. Just a minute, please go through this query. We proceed to the next concept. This is regarding the projection operation. Now, with projection operation, let us take an example, the combination of selection and projection. Slowly I am combining selection, projection, relational operators, greater than symbol, relational operators. Slowly I am integrating, I am combining all the operations. Project, name and rating. In final output, I should get only name and rating. In final output, I should get only names and rating. Of whom select rating greater than 8. The rating greater than 8. That is for UP rating is greater than 8. For Rusty rating is greater than 8. And hence their names, you get only names and ratings. For these rows, only names and ratings. You are asking to project only names and ratings. And hence in your output, you will get only names and ratings of the selected rows. The selected rows are nothing but rating greater than 8. Rating greater than 8. Rating greater than 8. This is the thing. It is a combination of selection and projection operation. Go through. Let's go through the next query. You observe here I am slowly introducing union operation. Union operation. This is a relation called sales 1. This is a relation called sales 2. Sales 1 and sales 2. There are two relations. This is salesman number, salesman name, gender, area of sales, north area, south area, east area, and sales amounts. Their sales amounts. This is one relation. This is another relation. Sales 2 is another relation. It also contains salesman number, name, gender, area, and sales amount. Here there are some extra tuples. You observe here, 111 is a tuple which is available here. You don't have that 111 here. Here in this relation there are common 101, 103, 105, 107. These are the common tuples here and there. The common tuples, and of course you are having 111 which is extra in S2, sales 2. The union operation clubs the content of first relation, second relation, eliminating duplicates. That is the union operation. The union operation, it combines relation 1 and relation 2, eliminating duplicates. And that is the reason here you are having 10 rows, and of course 101 is getting repeated, 103 is getting repeated, 105 is getting repeated, 107 is getting repeated, 111 is not getting repeated, and hence this 111 will be added. You can observe here from 101 to 110 you got, and even this 111 got added here. And this is the resultant instance which is extracted, the data is extracted from sales 1 as well as sales 2. It is a union, the combination of S1 and S2, the combination of this and this, you get this. Yeah, you please go through. This is a union operation. List out all salespersons from sales 1 and sales 2. All salespersons from sales 1 and sales 2. This is union operation. Please go through. We proceed to the next concept. Let us go ahead with the next example, intersection. Intersection. The common elements, the common tuples or the common instances of sales 1 and sales 2 will be resulted. You observe here there is sales 1, here there is another sales 2. And remember, it should satisfy the set operation conditions. That is, the number of columns of the first relation should be equal to number of columns of the second relation. Then only you can perform set operations. The second point, the data types, that is add tree or the data types should match. The first one is numeric column. Here also the first one should be numeric column. The second is string column. The second should be a string column, that is a character column, and so on. Then only it should match. Then only you can perform the operations. Here this is a intersection, that is the intersection. Right, list out the common salespersons from sales 1 and sales 2. He is asking the common persons who are existing in sales 1 and sales 2. 101 is common. 101 is common. 103 is common. 105 is common. Here and there you are having 105. 105 is common. 107 is common. 111 you don't have 111 here. Leave it off. And hence you will get 1, 2, 3, 4 rows. So you are getting the data of 101 because common. 103 is common here and there in sales 1 and sales 2. 103 is common. 105 is common here and there. You are having 105. 107 is common here and there, that is 107. So this is nothing but intersection. Intersection is the common tuples of sales 1 and sales 2 will be resulted. That is the purpose of intersection operation. Next slide. I am proceeding to next slide. Here now I am introducing selection, projection, union, and of course the relational operators. I am going with the projection operation. In this I am introducing selection operation, combination. I am going with the union operation, and of course the relational operator equal to. Slowly I am increasing the length of query with multiple concepts. List out the salesman names and sales amounts. I want only names and sales amounts, and hence in result you should not get this. List out salesman names and sales amounts. So in your output you should not get salesman number. That is first point. You should get only name and sales amounts. You should get names and their sales amounts, only these columns. You should not get gender. This is wrong. You should not get gender in our, you should not get area in your output. So you should not get this. You should not get this area. You should get only salesman name and sales amount. In the result you should get salesman name and sales amount. Select area equals to east. He is asking only eastern salespersons. He is asking eastern salespersons from both the tables. As he is saying, from both the tables I am performing union operation. From both the tables he is asking for east salespersons. That is the reason what I am doing, sales 1 union sales 2. I am performing union operation for sales 1 and sales 2. After performing union operation means all the tuples got clubbed. And from that I am selecting only area equals to east. So rest of the areas will be eliminated. Only eastern instances will be there. From the eastern instance I am taking name and sales amount. So you are selecting name and sales amount of only east salespersons. Now east salespersons means you will get Ganesh, you will get Lata, and you get Vittal. This will be the output. This is a portion you are going to get as output. This is a portion you are going to get as output, not rest, not this. You are not going to get this portion. Only you are going to get only this, because Ganesh belongs to east, Lata belongs to east, and Vittal belongs to east. You will get only the eastern salespersons, names and their sales amounts. You can go through this query one. It contains multiple concepts: union concept, selection concept, and projection concept. Multiple concepts are there. Right. We'll discuss the next topic. Here, the similar concept. The question is east males from both the tables. He want eastern salespersons, and that two males he require, and he's asking names and sales amounts. When he's asking names and sales amounts, in output you should not get salesman number. This is wrong. Names and sales amounts. So we don't get gender. We don't get area. Here, this is wrong. You will not get salesman number. You will not get gender. That is wrong. You will not get area. This is wrong. So you are getting salesman name and you are getting sales amount. Name and sales amounts. This is what I am interested to see. Project name and sales amount. You are projecting only names and sales amount. Select area equals to east and gender equals to end operator. You observe here and gender equals. There should be east males. So east males. East males means the date of Whittle. East males, the date of Whittle. Here if you observe east male, the date of Ganesh. East males, east and male, east and male, that is date of Ganesh. This is east female and hence this is filtered off. East male, you got the date of Whittle. And when I clubbed these two, all tuples of sales 1 and sales 2 got clubbed union. From that I filtered, from the union I filtered east males, and from the east male only names and sales amount, and hence you will get the name and sales amount, that is Ganesh 70,000 and Whittle 70,000. Ganesh 70,000 and Whittle is also 70,000. Ganesh is also 70,000. So this will be your resultant query. Yeah, you can just go through this selection, projection, union, combination. Just a minute, please go through. Just a difference. The question is, we want only the rows which are there. We want only those rows which are, only the rows which are there in second relation but not in first. I am interested to see the rows which are available in the second relation but not in first. Then sales 2 minus sales 1. This is nothing but set difference. Sales 2 minus sales 1. You get only the rows which are available exclusively in second, but and hence you get Mr. Whittle, male east. This Whittle row is not there in the first relation. Sales 2 minus sales 1. Sales 2 minus sales 1. In sales 1, what rows are available, that will be resulted. The rows should not be there in first relation. Here Vasu is there and you will not get Vasu. Padma is there. Here Padma is there. 103 Padma is there. So you will not get this. Giri is there. Giri is there. You will not get. Vani is there. Vani is there. You will not get. Whittle, you don't have Whittle here. And hence you will get this 111 as an output. You get this 111 as an output. You can see here you got 111. That is nothing but difference. Set difference. Right, students, I'll proceed to the next concept. Any doubts, you can unmute your microphone and you can ask me. I'm proceeding to the next concept. I'm just using the union operation, or you can evaluate a query in different forms. There is nothing wrong. In multiple forms you can evaluate the query, but shorter query is the best query. Shorter query is the best query. List out names and sales amounts. We want only names. I don't want this. Names and sales amounts. So you should not get gender. You should not get area. That is wrong. I want names and I want sales amounts. Names and sales amounts. I want names and sales amounts of females, of only females, except those females whose sales amount is greater than 80,000. Means the females whose sales amount greater than 80,000 I don't want. The rest of the females I want. Listen carefully. I want names and sales amounts of females, except those females whose sales amount is greater than 80,000. If that female is having greater than 80,000 sales amount, I don't want those females. The rest of the females I want. Now you observe here from both the tables. If you observe, I am performing union operation, sales 1, sales 2. When I perform union operation, both gets clubbed. That is the first point. From the clubbed data, with the selection operation, I am filtering. Gender should be female and sales amount should be less than 80,000. The gender should be female and sales amount should be less than 80,000. I clubbed. The first thing is I performed union operation between these two. Means all these rows got clubbed into a single unit. The sales 1 and sales 2, they got clubbed into a single unit. From that, I'm filtering, select gender equals to female They should be female and sales amount should be less than 80,000. The sales amount should be less than 80,000. I am selecting only those females whose sales amount is less than 80,000. Less than 80,000 females are Padma is less than 80,000. If you see Radha is less than 80,000, Radha is less than 80,000, and you are having Vani, no, 95,000. Vani is 95,000, and hence I am not considering Vani. And Rani is 65,000, I am considering Rani. And Lata is with 35,000, I am selecting Lata. Here 1, 2, 3, 4. I am selecting 4 tuples, right? And I am projecting their names and sales amounts. Only names and sales amounts are projected, rest are not projected. So output you can observe here Padma, you got Padma here. You got Radha and output Radha. And of course Rani is there in your output and Lata is there in your output. Right? The same query, this is the best way of doing. The same query can also be done like this, can also be done. What I am doing, I am selecting all females. By clubbing first one and second one, I am selecting all females. So from here to here, you will get all females. This is first portion, you will get all females. From here to here, you will get all females. From that I am subtracting the females greater than 80,000. I am subtracting the females with sales amount greater than 8,000. That is a minus operation. I am performing minus operation. So you will get all the females whose sales amount is less than, because I am subtracting greater than 80,000 rows are being subtracted, removed. Minus operation. Here I am performing minus operation. So that is being removed. Right. So you get only the females, names and sales amount whose sales amount is less than 80,000. So either way you can do, either this way or this way. This is a lengthy process. The first one is the comfortable process. This is the best process. This is the best process. Of course, you get answer like this. Using subtraction also you will get answer, but it is a lengthy process. So query optimization is very important. How short you write queries, that also plays vital role. You please go through these queries for a minute. So dear students, I am moving to the next query. I am going with a natural join operation. Natural join means when there are multiple relations. For example, there is reserves and sailors. This is the sailors table. This is the reserves table. As we discussed in the last class, there should be common column. Here, sailor ID and sailor ID. These two are the common columns. Based on the commonality, the rows will be junctioned. That is joined. That is a join operation. Here 22 and 22. This row will be joined with this. 22 and 22. This will be joined. The 22 and 22. This row also gets joined. 22 and 22. This row also gets joined. 31. Here you are having 31 labor. It gets joined. 31. Again here you are having 31. This gets joined. Again you are having labor. This gets joined. 31. And 64. Of course the 64 gets joined. And here the 64 again it gets joined. Here 74 and 74 gets joined. Only these rows will be joined. This is a natural join. As per the natural join, there should be a common column in multiple relations and the matching values will be joined. The matching values will be joined. Now, after joining, what we are saying, I want to select boat ID is 103. Names of sailors who have reserved boat ID 103. Names of sailors who reserved boat ID 103. So boat ID 103. Here you are having boat ID 103. The names of sailors, boat ID 103. Here there is 103. Boat ID 103. Here there is 103. Now you observe here, I filtered rest and I am selecting boat ID is 103. Boat ID is 103. And I want to see their names. I am projecting only their names. I am interested to see only their names. Their names I want to see. Now you observe here, if you look into this, here 103, the name is nothing but Dustin, and hence you got Dustin. And coming to this 103, the name is Labor. You got output as Labor. And coming to this 103, coming to this boat ID 103. Here you don't have any 103. Here you are having 103, 103. If you see 103, this is 74 Horatio. So you got output as Horatio. So the output is Dustin. This 103, this 103. Coming to this 103, it is a Dustin. Coming to this 103, it is a Lubber. Coming to this 103, it is Horatio. You got output as Dustin, Lubber and Horatio. This is output. Here I am performing the natural join. This is called natural join operation. You can go through this. You can ask me doubts if any. Let us go ahead with the next query. You observe here I am performing natural joins for multiple tables, more than 2. Previous example, we used two relations. Now I am going with the 3 relations. Find names of sailors who reserved red boat. Who reserved red boat? Here 3 relations are given. This is the boat's table which contains the colors of boat, red boat. This is the boat's table which contains the color of boat, that is a red boat. Here you are having red boat. The reservation details are in this table. Which sailor reserved which table? So which boat? Which sailor reserved which boat? This is a reservation table. Reservation details are here. And the sailor details are available in the sailors table. In the sailors table you are having sailor details. Now the question is, you want names of sailors. Means from this table you want names of sailors. Who booked red boat? Red boat. So boat color is in this relation. Booking details are in this relation. So I should mix up, or I should join all these 3. When I join these two tables, that is boat's table and reserves table. Boat's table and reserves table, based on the boat ID. Boat ID is a common column. Based on the boat ID common column, they get joined. What I'm saying, in boat's table I want only the color is red. Color is red. You pick up this, color is red. 102. 102 gets joined with this 102. 102 gets joined with this 102. And 102 gets joined with this 102. And you are having 104. 104 gets joined with this 104. 104 gets joined with this 104. This 104. So these rows are joined. And what we are doing, the reserves table is joined with sailors table. The reserves table is joined with the sailors table. This is the sailors table. The reserves table is joined with sailors table. And coming to these rows, 102, here 102, this row is 22. This row is having 22, sailor ID. The sailor ID, and here the sailor ID gets joined. The sailor ID, because this is a natural join. For this 102, 22 is there. This 22 gets connected with this. For this 22, the 22 gets connected. This 22 gets connected with 22. And here you are having 31. 31 gets connected with this 31. 31 gets connected with 31. And for this 104, you are having 31. This 31 gets connected with 31. Here for 102, you are having 64. 64 gets connected with 64. Now I am asking to project S name. That is the sailor names. And coming to the sailor name, the first one, if you observe these rows, it is a Dustin. And hence you got output as Dustin. And coming to these rows, it is a Lubber. These rows, the Lubber. So you are getting Lubber. And coming to this row, it got connected to Horatio, and hence you got Horatio. Here we are natural join. We are performing natural join between the reservations and boats, and reservations and sailors. Reservation boats, reservations and sailors. That's what we are doing. We are performing natural join operation among multiple tables. I went with the 3 relations. I performed natural join operation. Dear students, please once you go through. I'm proceeding to the next concept. Here a simplified query is there. Find names and boat IDs of their reservations. The question is very simple question. The previous one is a tougher because we are working with the three relations. Now the question is simple question. Names of boat IDs, names and boat IDs. He is asking to display names and boat IDs. That is the reason I am using projection. I am projecting names and boat IDs of their reservations. So who reserved which boat? That's what. When I use a natural join here, the common column is SID and SID. They will be connected. The common columns are being connected. SID and SID got connected based on the common values 22 and 22. Yeah, 22 and 22 got connected. This 22 and 22 got connected. This 22 and 22 got connected. This 22 and 22 got connected. Fine. Next 31. You're having 31. 31 and 31 connected. 31 and 31 connected. 31 and 31 got connected. Means 31 he reserved 3 boats. That is the lubber. He reserved 3 boats on 3 different dates. And of course the 64 and 64 got connected. The 64 Horatio and 64 got connected. So Horatio he reserved 2 boats. And here there is another Horatio 74 and 74. Coming to this 74 and 74, 74 and 74, they got connected. Here they got connected. 74 and 74, they got connected. And now you will get this output. But I want only names and boat IDs. The Dustin boat ID is 101. Dustin boat ID is 101. Dustin boat ID is 102. Dustin boat ID is 102. Dustin boat ID is 103. Dustin and boat ID is 103. 103. Dustin boat ID is 104 and so on and so on. Lubber 102 he booked 102, 103, 104. He booked these 3 boats. Horatio booked 101, 102 and 103. These are the boats which are being booked by these salespersons. You can just go through the diagram. How I am relating, this is important. How I am relating, that is a natural join. That is important. Right, students, with this, I would like to conclude today's class.